Hello dear, welcome. Let's discuss the next hard question together. Here it is our question. The statement of this question is, a train covered a certain distance at a uniform speed. If the train would have been 10 km per hour faster, it would have taken 2 hours less than the scheduled time. And if the train were slower by 10 km per hour, it would have taken 3 hours more than the scheduled time. Then find the distance covered by the train. Okay, so here one formula comes into the picture, that is distance is equals to speed into time. To remember that formula, we have a magic triangle as well: distance, speed and time. That is, distance is equals to speed into time, and speed is equals to distance upon time, and time is equals to distance upon speed, right? So by using this triangle, this scenario, we can derive all three formulae. Okay, right, so keep it aside. And here a train covered a certain distance at a uniform speed. Okay, so there is certain distance and the speed is uniform. So we don't know the speed, so let us assume the speed of the train is x, and the time also we don't know actual time, so that is also we take with some other variable y. Okay, let the speed of the train is equals to x kilometer per hour, and time taken to cover the distance is equals to y hours. And according to this formula, since distance is equals to speed into time, so total distance covered, how much? Distance is equals to x into y kilometers. Let us take this as number 1. Now here, according to the first condition, what is that? If the train would have been 10 km per hour faster, it would have taken 2 hours less than the scheduled time, right? So ATC1, according to first condition, this distance x into y is equals to speed into time. So here, if the speed would have been 10 kilometers faster, that is x plus 10, then it would have taken 2 hours less than the scheduled time. So time would be 2 hours less, that is y minus 2. So speed into time is equals to the distance, whatever actual distance, right? According to first condition, we have got one equation, we have formulated one equation. On simplifying further into linear form, this becomes xy is equals to x into y xy, x into negative 2 negative 2x plus 10 into y 10y, 10 into negative 2 negative 20, and from this again both the sides xy gets cancelled. So on shifting all the variable terms into left hand side, here negative 2x comes this side, positive 2x, positive 10y comes this side, negative 10y is equals to negative 20. Again throughout we can divide it by divided by 2. Here 2 1s are, 2 5s are, 2 10s are. Then this equation becomes x minus 5y is equals to minus 10. Let us take this is equation number 2. We have got one linear equation based on first condition. According to second condition, what is that? If the train were slower by 10 km per hour, it would have taken 3 hours more than the scheduled time, right? So distance remains same. Then ATC2 distance xy is equals to 10 km per hour slower, that is original speed is x, so x minus 10 into time it would have taken 3 hours extra, that is y plus 3. Speed into time is equals to distance. So we have formulated another equation. Now I am reducing this equation into linear form. So again we need to do some manipulations. So xy is equals to x into y, xy on multiplying these two, okay. X into 3x minus 10 into y minus 10y minus into plus minus 10 times of 3, 30. Again here both the sides plus xy gets cancelled. Then this becomes, on shifting this negative 30 into this side, 3x minus 10y is equals to 30. So we can write 3x minus 10y is equals to 30. We have got another linear equation. Now on solving these two equations by using any one of the algebraic method, we will get x and y. We will choose simpler method. So we will solve these two equations by using elimination method. For that we need to make any one of the variable term equal. So which one we will make equal? We will make y is equal, okay. Here negative 5y is there, negative 10y is there. So on multiplying equation 2 with 2, it becomes negative 10y, right. So on solving equation 2 and 3, we get, so equation 2 we are multiplying with 2, right. Then 2 into x, 2x minus 2 times of 5y, 10y is equals to 2 times of negative 10, that is negative 20. And equation 3 we are going to take as it is, that is 3x minus 10y is equals to 30. On subtracting, here we need to subtract because both are negative here. On subtracting, here signs will change, then this becomes positive, okay. So this becomes negative, this is positive, this is negative. Positive becomes negative, negative becomes positive, right. Here minus 10y plus 10y gets cancelled. 2x minus 3x, this is equals to how much? Minus x, minus 20 minus 30 minus 50. Again both the sides we can cancel, negative negative, that is both the sides we are multiplying with negative sign, right. Then we have got x value, that is 50. We have got x, that is speed of the train, 50 km per hour. Now we need y, that is the actual time taken to cover the distance. For that, substituting this x value in either equation 1 or equation 2, we will get y value. Where we will substitute? Good. We will substitute in equation 2. Now putting x is equals to 50 in equation 1, then equation 1 becomes, we get 50 minus 5y is equals to minus 10. On shifting this 50 into other side, here it is positive, other side it becomes negative. Then minus 5y is equals to minus 10 minus 50, both negative negative. So we can sum up, so negative 60. So again both the sides we can cancel negative negative because on multiplying with negative sign, as well as 5 and 60 both are multiples of 5, so we can divide both the sides with 5, right. Then 5 ones are, 5 12s are, 5 12s are. Then we have got y value 12, that is the time taken to cover the distance, that is 12 hours, right. X is 50 and y is 12. We have got x and y, but actually what we need to find? We need to find the distance covered by the train, that is from equation 1 the distance covered by the train is x into y, right. Therefore the distance covered by the train is equals to x into y, which is equals to x is 50 and y is 12, so which is equals to how much? 600 kilometers. So we shall discuss once again briefly. Here the question is, a train covered a certain distance at a uniform speed. If the train would have been 10 km per hour faster, it would have taken 2 hours less than the scheduled time. And if the train were slower by 10 km per hour, it would have taken 3 hours more than the scheduled time. Then find the distance covered by the train. So we have a relation between distance, speed and time. So first here we have taken speed of the train is x km per hour and time taken by the train to cover the distance, that is y km per hour. Then by using this relation, distance is equals to speed into time. So the distance covered by the train d is equals to speed into time, that is x into y kilometers. Let us take this is the equation number 1. So we need to find this one finally. So for that we required x and y. So according to first condition, distance remains same. If speed is 10 kilometers faster, that is x plus 10 into, it would have taken 2 hours less than the scheduled time. Time would have taken 2 hours less, that is y minus 2. So speed into time is equals to distance. So on reducing this equation into linear form, we have got one linear equation. We have given number 2. According to second condition, if the train were slower by 10 km per hour, that is x minus 10, then it would have taken 3 hours more than the scheduled time, that is time must be y plus 3. Again speed into time is equals to distance. On reducing this into linear form, we have got another linear equation. On solving these two linear equations by using any one of the method, whatever method you are comfortable, you can solve it. Here I have solved by using elimination method. Here we have got x equals to 50 and y equals to 12. So therefore the distance covered by the train is equals to, from equation 1, what is that? X into y, that is 50 into 12, 600 kilometers. Clear? This is it.